Okay, so today's lesson should be pretty short. We're going to be multiplying monomials together. And remember, what is a monomial? A monomial is a number or a variable or the product of a number and one or more variables. So that's what monomials are. So, for instance, k to the third power is a monomial, and also k to the second power is a monomial. And if you recall, what do we do with exponents when we're multiplying, two monomials that have the same base? Okay, all we do is add the exponents. So k to the third times k to the second would be k to the fifth power. If we did, let's say, just another example, p to the negative third, that's a negative third. Let me change that so it looks more like a 3. Okay, so then we have p to the negative third times p to the fourth, which equals p to the first, which is just p. Okay, another example, you can also have the variables down in the denominator, and it works exactly the same way. 1 over h to the negative second times h to the fourth would just equal h to the second. Okay, now we look at another example. R to the fifth times r to the negative 10th equals r to the negative fifth. And we know that we don't want to have any negative exponents in our answers. So what we need to do then is move the r to the negative fifth into the denominator, and it becomes 1 over r to the fifth. Okay, now if we have monomials that have coefficients in front of them, then we need to figure out what we do with the coefficients. So 3c to the negative second times 4c to the fifth, we would multiply the coefficients together and get 12. And then we would add the exponents of c. Negative 2 plus 5 is equal to 3. So our final answer would be 12c cubed. Okay, another example, if we have 8d to the negative third, and then multiplied it by 5d to the negative second, okay? Once again, multiply the coefficients. 8 times 5 is 40. And then and then add negative 3 and negative 2, and you get negative 5. So multiply the coefficients, add the exponents. And what happens if we have different bases within different variables within the same problem? So say, for instance, we had 4d to the negative second, e to the fifth, and we were multiplying that by 6d to the fifth, e to the seventh. Then what we would do is multiply our coefficients and get 24. We would add d to the negative second, negative 2 and 5, and we would get d to the third. And then we would add the coefficients on e and the 5 and the 7 and get 12. And I am just realizing that up on the problem above, I should have done something. And hopefully you caught it and realize what the extra step I should have done was. But what I should have done in the problem up above is not left a negative exponent. So you want to make sure you don't leave any negative exponents in your final answer. So it should have been 40 over d to the fifth as my final answer. No negative exponents in the final answer.